This is a demo for Novlum's Manhole Inspector tool, version 1.0.
First, I'll start the application, and you'll see that the layout is very similar to Novlum's Unitank application. To load a dataset, I'll use the big manhole button at the top left and pick my file from the dialog windows. I'll be using 3 different datasets of manholes that are connected to each other. After loading it, it shows up in the contents tree in the left window. To show it, I can check off the individual layer or choose Check All. I can zoom in and out using the mouse wheel, pan around using the left mouse button, and rotate using the right mouse button. If things disappear when you zoom in, it could be because the elevation of the view center is significantly different from the data. I can quickly switch between top-down and side views using T and S shortcuts. Be sure that the center of your view elevation is close to the data before zooming in further. The first thing I'll do is save the file as a PT3 file. This is Novlum's own point cloud data format that loads and saves much faster. In the color menu, I can choose to colorize things randomly, which will help me distinguish the scan layers. I won't go over registration here, but the process is very similar to Unitank. There are also some manual tools for nudging or rotating data layers. I can choose to move everything, or a specific point cloud or a definition in a layer. I can also hold down to Ctrl-Shift left-click to move data around, or I can hold down Ctrl-Shift right-click to rotate the data. There are a few choices for a center of rotation. The lid and manhole options will only work after I define the lid and manhole shaft. Now, if we look in the info pane, we can see that at this point the data is not correctly geo-referenced. It is just in a generic world Mercator projection. We can manually change the projection of the dataset using the Change Projection button and manually shift the data using the Advanced Translate function. New in version 0.2 is the ability to connect to a GIS server. For this dataset, the stormwater and wastewater data is publicly available from the New Plymouth District Council. We can download the data by clicking on the GIS Import button. If our screen is already centered on the actual work area, then we can use the first option. However, since it is not, we can manually enter the GPS coordinates for the area we want to download. The downloaded data shows up in the contents tree window on the left. I can view the data by checking off the layers and then right-clicking Go To. Note that the data is in the NZGD2000 projection in the info window. Zooming in, pipes are shown by lines and manholes are shown by 1 meter circles and do not correspond to the actual diameters of the manholes. Now, my data is still located near 00 in a generic World Mercator projection. To bring it to the right place, I can click on the Match to GIS button. After I choose the name of the manhole to match to, the data is moved to the approximate location of the manhole. The rotation may be incorrect depending on the scan orientation and whether the compass was enabled on the scanner. Holding down Ctrl and Shift, I can left-click drag to move and right-click drag to rotate the data into place. It is not important to get it to match the GIS data exactly. Next, I'm going to define the location of the manhole lid. Toggling between top and side views, I want to move my screen center to the elevation of the top of the lid, and then use the circle tool by pressing C to define the manhole circle. In the Definition tab, I can click the Lid button to define the lid. If I have GIS data loaded, then I'm given the option to match this to an existing manhole. Next, I can enter the actual coordinates of the lid. If I matched to a GIS manhole, then the coordinates are populated from the GIS data. I can change these if necessary, as the GIS manhole location may be less accurate than the new survey. The manhole definition is created inside a layer called Structure. To properly rotate the data, I also need to add a survey point. To do this, I press Q to select the point tool and then place a point corresponding to a known survey point. In this case, I know the GPS coordinates of this building. Next, I can use the Move Data button to move everything exactly to the coordinates that I entered. The coordinates of the screen center and cursor are shown in the info on the bottom left. If I ever lose my place, I can click on the Go To button to jump to my manhole lid again. Similar to the lid, I can use a circle to define the top or bottom of my manhole shaft. I can also use a polygon if the manhole shaft is not round. Next, to define pipes, I want to constrain the visible point in Z so that I can see the pipes more clearly. This can be done by setting the min and max Z in the menu. There are 3 ways to define pipes. The first is Find Pipe. To use this, press P for the polygon tool or R for the rectangle tool and select some points containing the pipe from a top-down view. Then click on the Find Pipe button and select the extents in Z of the pipe. If I have a GIS dataset loaded, then I can match with an existing pipe so that data, like pipe material and asset numbers, are automatically assigned to the pipe. Because thickness may not be stored in the GIS, the thickness is estimated based on the pipe diameter. If you can't find a matching GIS pipe or don't want to match one, then you can also manually choose the nominal pipe size. After pressing OK, if a pipe is found, it shows up with a green outline. In this case, we failed to find a pipe because the diameter from the GIS is actually wrong. If I try again with the correct pipe diameter, then a pipe is found successfully. The pipe definition is pushed as far as possible towards the manhole. If the pipe end isn't quite in the right place along the axis of the pipe, I can use Q for the point tool to define a point, and then press Set Pipe End to move the pipe definition to the right place. Sometimes pipe finding may fail because the Z range is not tight enough to the pipe and there is too much extra data. Try again with a reduced Z range. If a pipe still cannot be found, maybe due to noise or lack of coverage, another method for defining the pipe is to draw a circle denoting its interior. First, move the screen center in top-down view to the center of the pipe end with the pipe pointing up. Then change to a side view, and then use the circle tool to draw the inside of the pipe. Pressing Define Pipe Interior shows a window where you can input details about the pipe. Sometimes the interior of the pipe may not be visible. The last method for defining the pipe is to draw a line denoting its top. First, move the screen center in side view to the outside top of the pipe. Then, in top-down view, draw the center line of the pipe. Pressing Define Pipe Top shows a window where you can input details about the pipe. If you need to adjust a pipe definition, in the Registration tab select Type Definition and then choose the pipe from the Layer menu. All of the manual registration tools will now work on the pipe definition. If there is too much clutter hiding the pipe end, you can just show the ends of the pipes using the Show Pipe Flanges button. This enables you to just show the pipe definition and endpoints so you can line things up accurately. You can also edit, copy, or delete definitions in the Edit menu. Although it is not recommended, it is possible to change or fill in GIS data for pipe and manhole definitions too. Finally, we need to enter in some details about the manhole for reporting. If I want a view of the inside of the manhole from one of the pipes in my report later, I can choose which pipe to look in from. I also want to constrain the Z for the points rendered in the report. If my project contains multiple manholes, I can import new data and repeat the process with other manholes. I can switch between the manholes by selecting a different active data set in the drop-down menu. Now, if I zoom out, I can see the different manholes that I have in the region, all properly geolocated. I can click on the Auto Connect button to automatically create connections between pipe ends. This is done by matching the GIS asset IDs from the different pipe definitions. If the pipe definitions are missing asset IDs, then it's also possible to manually create connections between the pipes by pressing L to select the line tool. Then I can draw a line from one pipe to another pipe and then click the Add Connection button. I can also create a connection to a fixed point by creating a line to open space. The Update button is in case I move or rotate one of the manholes and the connections become out of sync. Finally, I can hit Generate Report to create a Word document. All loaded manholes will appear in the report. When I open up my report, I can see the details of my manhole, pipe elevation measurements, and diagrams of the scan points. There are also cross-sections of the pipe ends that I can use to check that my pipe definitions have been properly drawn. Values that are different from the GIS are highlighted with an asterisk. I can also hit Export Data to export my definitions to a DXF CAD file. Inside a CAD viewer, I can see the details of my manholes and connections. This concludes the quick overview of the functionality of Novlum's Manhole Inspector.